Welcome and thank you for the invitation. Today I'm gonna talk to you a little bit about aquaponics. My name is Joe Masabni. I'm the small acreage extension vegetable specialist at Overton Center. I gonna treat you to a few slides and ideas that nobody has seen before. So your lucky day. About what I'm doing with aquaponic research in my greenhouse at Overton. You are always welcome to come visit if you like a tour or you want to have a program here or you're passing, driving through and you want to stop by. Call me, email me, and if I'm here, I'll be happy to give you a tour. Okay, so what is aquaponic? This picture is taken at our research center in South Texas in Weslaco. You can see what I'm going to show you here. What I want to tell you from this picture is that you see tomatoes, you see lettuce, you see, it on a bench. When you see the different ideas of whether YouTube videos or visiting people or whatever, it can be done in many ways. I'll tell you in detail about my system, but there's more than one way to build it as long as you understand the concepts and what is really important. The physical design is not important. We made it work with 6 inches of water, even though everybody else says, oh, it's got to be 12 inches of water in this type of aquaponic called deep water culture, which I will go in a little bit more detail. As a hobbyist, I recommend deep water culture, and I'll show you what I mean. There are three types of ways to grow in aquaponics. Even as a home hobbyist, I recommend something like this. It doesn't have to be on a bench, but there's basically you have the white foam, what you see here. Let me turn on the pointer. What you see here is white foam that are 2 by 4 pieces, have holes, and there are cups, and the plant sits in the cup, roots in the water. So there's water under all this white foam. And that's why we call it deep water culture. Okay, next slide. So what is aquaponic? Aquaponic is combination of aquaculture, which is raising fish in a densely stocked tank. In aquaculture, like you see in this picture, this is a fish raising operation. That's all they're growing fish, raising fish. The problem with this is that you produce a lot of waste from fish, which you need extensive filtration. Hydroponic is the farming of plant in a soilless environment, whether in tubes like you see in this picture with running water in the tubes, or in media bed, or in gravel. So they need a lot of nutrition. So you combine the two, the aqua from aquaculture and ponics from hydroponic, and you get the word aquaponics. So it's the combination of both growing fish and hydroponic technology, meaning growing plants without soil, not in the field, not in the ground, in a recirculating system. The plants help you with taking care of the waste, and you don't need fertilizer for the plants because now you're getting free fertilizer from the plant waste. So it's a mutually beneficial system. So I've been talking about fish and plants. The third leg of that three-legged stool that you don't see, you see fish, you see plants, you don't see bacteria, but they are the heart and soul of the engine, if you want to call it an engine of that system. because without the bacteria, nothing is working. And I'll show you why. So really, and everything you do in terms of measuring pH, EC, temperature, ammonia, nitrite, nitrate, when you are taking these measurements once in a while, you're indirectly measuring the health of that bacteria and to see if they are still there doing their work because you can't see them. So fish, plants, and bacteria, even though people talk about aquaponics, fish, and plants. And here are the factors that are involved in the aquaponic system: pH, temperature. I'll read a few of them: oxygen in the water, filtration system, ammonia, ammonium, nitrite, nitrate, air temperature. And this is how they interact. And I will quiz you at the end about all these arrows. So memorize this if you can. So so like I said, I measure ammonia, nitrite, nitrate, pH, alkalinity, water temperature because they affect fish, plants, and bacteria, and that's very important. So here is a simplified concept of aquaponics. The fish produce the waste. The waste goes to the media where the plant grow. The plant take up the nutrient. So let's call it they're filtering it. They're cleaning the water. And then the clean water returns to the fish tank. Now, by clean, don't assume that clean means drinkable quality water. No, but it's the concept here is that without the plants filtering some of that waste out, the plants, the system is contaminated with excessive waste. That's what by I clean here. Relatively clean. The fish produce the waste, the plants clean up the waste or some of it, and then the system continues. All right, so what are the three types of aquaponic systems? The most common one that I see when I visit homeowners is this type, the media bed, what you see here. Okay, this works on the principle of flood and drain. The water comes in from here, continuously pours into the bed, fills up the bed. There's a siphon here that automatically kicks in when the water reaches a certain level, and the siphon kicks in and then drains it. So you can imagine the water filling up the bed, and when it reaches a level, drains it down. And then you plant your plants here, okay? So the roots of that plant is sitting in that gravel, and they are continuously being watered and then drained, watered and drained with nutrient-rich water. The ideal material to use is the expanded lava rocks, but they are very expensive, so homeowners switch to gravel, switch to other type of material that doesn't really work. But but it's a lot cheaper. This bed here, if you were to fill it with that expanded shale, it'll cost you about $500, whereas you can get free pebbles from the riverbed for free. So that's the disadvantage of that. There is a company. The picture on the right shows you a system that a company in Austin called Aquasprouts. I don't get kickbacks from them. I just want something for you to learn and enjoy. And they can sell you the whole system. You tell them I have a 10-gallon tank or a 50-gallon tank or whatever, and they'll sell you everything that goes with it, including the media, the siphon, the lights, everything. So you have a mini aquaponic system to build around your aquarium. And this way you can remove the filter from that aquarium because now the plants are filtering and you get some herbs, some flower. Of course, in a 2 by 2 area here of production, you're not gonna save money. It is just to grow something that you like. It's a hobby, enrich your life, not save money on the grocery bill. So that's the media, or what I like to call flood and drain system. The other system is just like a typical hydroponic system. If you've seen them with the tubes, like these tubes here, with the water continuously running, continuously running, because these tubes are at a gentle, like 3% slope, so the water comes from one end, continuously running. The roots of all these lettuce plants are in that water, and they take up the nutrients from that water. Okay. It has advantages. Lots of commercial operations like this system, like this. I don't recommend it for a homeowner because it's very finicky and it can crash really quick. It's not forgiving, like the deep water culture. But hey, if you know how to use it, if you already have it, it's very easy to connect it to a fish tank and convert your hydroponic to an aquaponic. It's not forgiving because it can easily heat up. Remember, there's a thin water layer running in under those tubes. That means the water can, in the summer, can warm up really quick. So you may not get the best production possible. Deep water culture is the third one. This is the most practical commercial application, and even a homeowner, I think it's best. So again, this what you see here is the foam floating on the water, and there's about a foot of water here. The foam has holes. The plants sit in cups. The roots are in the water. And the reason roots do not rot being completely immersed in water is because you have to add oxygen to that water. You don't have to add oxygen here in this system because the water is continuously running, so it's getting aerated. You don't need to add water in the media bed because the roots are flooded with the water, but then they get drained, so they get oxygen. And usually that cycle takes about 10 minutes, so you're never flooding the roots for too long to choke them. But in this system, you definitely need to add a lot of air pump to pump in water and keep your parts per million dissolved water around 5%, 3 to 5%. Okay, this is 8 foot wide bed. Unlike a raised bed in the garden where we tell you keep it 4 foot wide, so you don't have to step in it. These can be as wide as you like because you don't have to step in the water. This is a floating foam pad. You can just grab it and bring it to you. It slides on the water. So that's the beauty of this system. Okay. Moving on to a schematic diagram of my system, and I'll show you a picture of it, and I tell you why I did what I did mine. Starting on the right, I have 2 fish tanks, 100-gallon each. The water goes from one tank to the other by gravity because the first one is higher than the second one, which is higher than this first radial filter. And then from the radial filter, which is really a settling tank, I'm mechanically trying to settle all the waste so they don't reach the grow bed. The water from the radial filter goes to my biofilter. Another name for it that I like to use is the digestion tank, where I like to think that all the bacteria are there and they do what they do and convert the waste into nutrients. and then they go to sump pump, like a tank, and then from there go to the bed. And so far up to this point, so from the first tank on the right to this point here, everything is, the water flow is by gravity. And then there's a pipe that goes all the way back to this point where I have my water pump. So maybe let's say to this point is by gravity, and then from this point the pump pushes it up 4 feet in the air to dump it back in the first tank. So from here to here to here to here to here, here, all the way, and then all the way back, all is that by gravity. Okay, sorry, now it's getting crowded. And this is an air pump. Actually, I have three of them, but this is an air pump that's pumping oxygen here. I have another one here with 5 lines pumping oxygen into the bed. And I have one for this tank, and I have one for this tank. You cannot add too much oxygen in the water, especially in our hot Texas climate. Okay. I have an extra tank, a sump tank, because with some switching of valves, I can separate my fish from my plants. So my aquaponic system can become aquaculture with hydroponic. For example, let's say I want to spray something on the plant to kill insects and not kill my fish. I can separate. So now this pump, this pump will circulate the water this way. Okay. So now this will become a single loop, and I can add my hydroponic fertilizer into this tank. So now this is really a hydroponic system for a week or 2 weeks until I know the plants are safe, and when I reopen the system, I'm not going to kill my fish. And the water flow from the fish will go this way, this way, this way, but instead of going back there, now I redirected it to go this way, and it becomes a closed loop for my aquaculture to avoid killing my fish. Another example is, let's say I want to add salt to my water to cure a disease. So the fish have disease, and I want to add salt, and if I don't want the salt to kill my fish, I can separate my system. I don't know anybody who has done this and only took an extra tank and an extra some extra valves and an extra water pump, and hey, maybe you want to consider doing something like that. It's not that expensive. So here is a picture when we were building the system. I had a couple of classes. So on the top right photo, you see the first fish tank is higher. It goes down to the second fish tank. Each one is a 100-gallon tank. This is the radial filter. And then so the water goes from here to this tank. This is the settling tank I told you for physical separation of waste, and the water goes here where the bacteria are, what I'm calling digestion tank, then goes to this sump pump, to this sump pump, sump tank, and then here is that one, and then the water drops on top here, and then fills up this bed, enters the filter, goes back out here, comes here, and here is my pump that will pump the water back and dump it here. Okay, so you need a water pump and you need air pumps running 24 hours a day. So keep that in mind. They don't consume a lot of electricity, but if you think you're going to be in a power outage more than 2 hours, you may need a generator. The plants may not die, but if it's July and in the middle of August and you have 24-hour power outage and the water temperature is 80, next day all the fish are dead. Okay, so Backup are very important. I have extra water pumps sitting ready in case it dies. You know, they're running 24 hours a day. Maybe in 6 months it dies. I have air pumps backup ready, and I can switch them in 5 minutes. And I have a backup gas generator that can generate electricity until the electricity comes back. So keep that in mind. Okay, I mentioned the bacteria, which is the heart and soul of the engine, and here is why. The fish excrete ammonia, make ammonia with their waste and through breathing from their gills. Now, let me open parenthesis here and say, when I say waste is the source of food for the plants, that is misleading. It's not the solid waste that we are talking about. Well, solid waste is useless to the plant or to the bacteria. It's the ammonia that's in the waste and from breathing that we want. It is a waste for the fish, but we don't when I say waste, think, oh, the solid waste of the fish. No, that's why I have settling tank to separate the solid waste and get it out so it doesn't plug the system and ruin it. And the ammonia is what we want from the waste. So the ammonia is produced, and there's one type of bacteria called nitrosomonas that will convert it to nitrite. And there's another type of bacteria called the nitrobacter that will convert it to nitrate. And that is what the plant uses, the nitrate. And then the plants take up the ammonia and the nitrate from the water. And in chemistry, if you like a chemistry lesson, we say if you remove nitrate, you are encouraging this forward reaction. You are encouraging this forward reaction. In chemistry, there's something called feedback mechanism. Let's say you don't have plants and this nitrate concentration accumulates. Feedback reaction means nitrate starts to accumulate and ammonia starts to accumulate because the conversion slows down. And that's what we try to avoid. If you can reach 5 parts per million ammonia that is produced by the fish, it kills them. So what they produce ends up killing them if it's not converted to nitrate. That's why we measure pH, EC, and all that to make sure that nitrate is very low, ammonia is nitrite is very low, ammonia is very low, and nitrate concentration is sufficient for the plants. Tongue twister trying to say nitrite and nitrate. Okay, so these are kind of crops that are grown and that can be grown. Basically, you can grow anything. Commercially, a tomato may not be a good business decision because of how long it takes and how much surface area it uses, and et cetera, where compared to basil, compared to lettuce. Lettuce is the king of the aquaponic industry because in 30 days from seed to harvest, you're done. But you see Swiss chard, you see kale, you see all kind of things. And here the top picture shows you the roots of the plant. This gentleman here lifted the foam board so that you see what's underneath. You see nice, healthy, white roots that are in water, which is usually want to do that once in a while to see if they're brown, if they're rotten, health indication of the system. This grower quit the bottom right, quit growing, kale, because look at the extensive root system that it made from one plant. It basically plugged the water flow. So he said, I can grow it, I can produce it, no problem, but look, I can't afford all this root, and there's no more water, clean, strong water flow in there. Okay, so you can grow it, yes, but it may come at a price. This picture shows you an experiment we did in South Texas at our research center there. The seeds, 14 days for sowing, germination, initial seedling growth, and then in 20 days, so it was put in the aquaponic system on July 8th, and by July 28th, they were ready to harvest. So the total is about 34 days from seed to harvest. And the reason hydroponic and aquaponic are popular is they use 10% of the water that you would need to grow the same crop in the field. So because the water is recirculating, you're not just dumping out water in the field, and a lot of it is, leaching. So what are your inputs? What do you need to buy and have on hand? You need a complete fish feed, 34% protein or higher for younger fish. You need pH adjuster, and more than likely that you need something that will push pH up, pH upper, not pH downer, pH upper, because if everything is working, the pH will tend to go down. So you need to add pH to raise it. And for example, calcium carbonate or potassium bicarbonate, have something on hand. In my 900-gallon system, 3 ounces of calcium carbonate is enough to raise my pH from 5.5 to 6.5. So you don't need a lot, but you should have it on handy. If you think you want to be commercial and sell, there are lots of licenses. I'm not going to go into detail, but you have aquaculture license, exotic species permit if you want to raise exotic species, wastewater discharge permit, and flood zone declaration. You don't have to deal with this if it's all for home consumption, but keep these in mind in case somebody or you're interested. Okay, and now we switch to pictures I have taken from homeowners or from my system. This is a homeowner, beautiful system where the water, let me turn on the mouse, the pointer. So here is a big fish tank, and he has blue Nile fish, and the water is being pumped into these 3 tubs, flood and drain, and you see he has volcanic rock, and they fill up, and then the siphon, this siphon, this siphon, this siphon kicks in, and then they drain, back down here. So it's a closed system. He's growing lettuce, basil, he has some fern. He put a grapevine to root it, so it can get some roots. He put a stick and so it gets some roots before he plants it outside. It works really well for him. He's not going for yields. It's just a hobby and to grow a few plants for the fun of it. Here's the close-up. You see there's moss growing. There's a lot of debris from the fish waste solids that are accumulating here, and bacteria growing on it, and moss. So once in a while you have to clean it. You have to remove all this, wash them out, drain them. Otherwise, it will become become real messy. One disadvantage that I pointed out to him is because you have a media like this media, and it can encourage insects to live there and hide. And since you can't spray, look at the worm came here and took a big bite of his lettuce. You can't spray. You don't want to kill your fish. So, but once an annual, maybe cleaning up of the system, shut it off, remove all this, wash it, put it back in. Maybe is a great idea. Okay, and this is again a homeowner system with a deep water culture. Again, this is the foam. Um, Very nice idea. These are 4 by 8, and the water by gravity goes from left to right, and then the pump pushes it back up next to the house. A few beds. I mean, what you have about 80 plants per bed, growing lettuce, growing tomato, growing wintergreen, and he built his own cover to drop it and cover it on colder night. Very ingenious idea. I like it. Um, and that's the homeowner. He even had a heat light on very cold night to turn on the light so that the plants don't freeze. Okay, I'm gonna skip through this. I have two systems because I want to do an experiment comparing high fish stocking density, or commonly known as high density planting, and low density planting. And let's look at some numbers. In the high density planting, that you need anywhere between 16 to 30 pounds per 200 gallon in my system, compared to a low density system that you need 1.6 to 8 pounds in 200 gallon. So I'm doing that, and I'm comparing one to the other to see which is better, which will give me more yields, which will, easy to operate, etc., etc. Okay, because there's lots of ideas, and everybody thinks their idea is the best. I am doing the research and to be unbiased and hopefully give better recommendation. All right, I'm gonna skip through some of these pictures. Here is one idea. I put a shut-off valve and the water turned on, or this way if water is lost from evaporation or being used by the plants, it can automatically refill. So that's an idea. And this is the picture of the air stone sitting at the bottom of the tank. That's where the oxygen comes out. That you buy them. If you like, I can send you a list of all the parts that I use in my system and where I bought them from. And it's showing you filling up. This is one of the gauges I use that can measure pH, EC, which measures the number of ions in the water. 313 is great. Anything above 800 is iffy. You don't want. And I've seen people using water with 1400, and that's not allowed. I mean, and no wonder their plants were dead, because I told them you have trash water. It's like salty water, like ocean water. You got to get a filter or something, or quit. I have 300 great water. And here's a picture of my two systems. The one on the right is what I'm calling the high density. The one on the left is the low density. You see our water has iron in it. So when it filled up, this is initial when it just filled up. So the iron didn't get a chance to settle, and I haven't put the foam yet. I recommend you consider buying bacteria to kickstart the system faster. I mean, you can put fish, and then bacteria will build up with time because it's in them, it's on them. Or you can add it and save 3 weeks and instantly start converting ammonia. So what I did, I bought bacteria, I bought clear ammonia, and I added them, and within a week I started seeing nitrate. So I knew that the ammonia is dropping, and the bacteria, now I have nitrate. I can add fish, and I can start adding plants. When I added my fish, and it's a small 100-gallon tub, I don't know if they're jumpy or scared or whatever, but they started jumping out of the tank, committing suicide. So with wood or PVC and some garden fabric, I built a cover. Fish don't need light. They don't need to be in the light to be happy. So, hey, keep them covered so they don't jump. This is the foam sitting in my water. You want a little bit of gap so the foam can slide and move, but you don't want a big gap because you don't want algae, you don't want duckweed, you don't want things to grow in there. Okay. Um, how skip this? I had a leak. I had a big leak, and one day I came in, and the whole 600, 300, 600 gallon here was drained. But it was a nice educational picture to take um, because when I look at all these islands here, I mean, look at all these islands, what I'm calling islands of clear. Remember, my water has a lot of iron. Uh, if all the iron settled, I should have a clear brown layer at the bottom. Why do I have these islands of clear without the iron? That is where the bacteria is growing and is using up that iron. So if you have a system and you see islands like that, you know your bacteria is doing well. So even though this tank on the top, if you can follow my pointer, that is where I'm calling the digestion tank and where I think where it's supposed to be, but in reality, bacteria is everywhere. It's not localized. Where there's water, it will move with the water. Okay, so where was the leak? After a lot of the leak was from the exit here. So I put silicone on the outside, put silicone on the inside, and so what I recommend is if you don't want to go through my mistakes and draining and refilling and draining and refilling, put silicone everywhere. Do not trust that these brackets will have a seal. Put silicone everywhere just to be safe. Okay. And another tip I encourage you to do if you need to weigh your fish or calm them, to move them from one place to another for any reason. You want to clean your system, you want to put them temporarily in a tank to clean and drain and wash and restock your system. You need to use a clove oil. Clove, CLOVE, clove oil is anesthetic for the fish. So I put a few drops of clove oil in this tub, harvested my tilapia, and 10 minutes later you see them floating to the side or floating upside down. They are not dead because you can still see them breathing. They are just anesthetized, like sleeping. Okay, it calms them. It gave me a chance to count them, weigh them, to do some research on them, um, and I took some numbers. I'll share quickly with you. So my high density, I started with 25 pounds. I lost 4.5 pounds. They jumped, they died, they were sick, whatever. In theory, they should have been 20 pounds. When I weighed them, they were 22.6, so they gained 2.2 pounds. The same thing for the low density. Started with 5 pounds, lost 1.5. They should have been 3.4. I weighed 4.28. They gained 0.88. Yeah, the ratio of gain is the same between the two, so they are growing. Usually, fish are harvested when it's about a pound apiece for tilapia. So this picture taken on January 8th when I did a small experiment with bok choy. On the right is my high density with the higher fish and meaning more fish, meaning more nutrient. And on the left is the low density, low fish means low nutrient. And I wanted to see, is the high density better? Will it grow better? Will it grow faster? Or not, you know? So this taken on 1/8, this taken on 11 days later. And you can see at this stage that the high density on the right, the plants are bigger than the one on the left. So in my situation, I can see definitely a benefit of more fish, more plants. Now, look here, why a lot of them are dead, because I had a beetle that ruined me, chewed up a lot of the holes, and I found it and I got rid of it, and it's yellow margined leaf beetle. So it was a disaster. I sprayed neem oil and I got rid of them. And you see here, about a month later, you see on the right with the high density, nice deep purple color for that red bok choy compared to smaller plants that are paler in color. So definitely more nutrient, more plants. You mess up your system, this can happen. I killed all my tilapia fish in 3 days because I tried to clean the tank and I disturbed all the sediments and made the system anaerobic, meaning no oxygen, and they all died. So live and learn. I tried all kind of things, and I finally one of the things I'm trying is this paint strainer bag that you can find at Lowe's and Home Depot to run the paint through it to filter any solids. You know, so here's the bag and here's a clamp. I put it around the pipe connecting from one tank to another. See, I put this on May 20th, and 2 days later, it was full with solids. Imagine all these solids could have stayed in the water and settled at the bottom, or maybe even killed the fish. I mean, you imagine you breathing dust, room full of dust, 24 hours a day for a year. You're gonna die. So you need. That's why solids uh, and taking care of solids is very, very important in whatever system you are dealing with. I'm trying quickly. I'm trying an idea with rock wool, loose rock wool. This is a Texas company that I gave me this bag, and I'm trying it, and I'm germinated it, germinated lettuce seedlings, made my own cups, and they're growing real well. It's a lot cheaper than the commercial prefabricated rock wool that you use. I like it. And after harvesting the first bags of lettuce, I what do you call it? Reused that same rock wool, so it's reusable. I like save even more money. I'm also trying this Grow Grip, which is a piece of foam. Let me turn on the pointer, which is a piece of foam. Here's one, and you see it has a slit. It has a slit here. So when you pinch on this end, it opens, and you can slide that seedling. You can slide that seedling in the slit, and when you close it, and it fits in the hole perfectly. So this is another idea I'm trying. I think a commercial grower may like it because you don't need cup anymore, and you don't need rock wool anymore. So so it can be reusable when the rock wool is a one-time. The commercial rock wool is a one-time use. The cup, of course, you clean it and reuse it. And here it is. You see, you don't need the black cup anymore, the net cup, and you don't need media anymore. This just slides in the hole and it fits perfectly, and the roots are in the water, and they're doing great. And this is the same plant picture I took a couple of days ago, and it's ready for harvest. I should have harvested a week ago, but I've been busy. The plants, they're doing great.